All right, let's dive deep underground, and I mean really deep, to get a handle on the stuff that basically powers our entire world. Petroleum. We're going to break down what it actually is, and maybe more importantly, how these massive geological structures manage to trap it and create what we call a petroleum reservoir. I mean, think about it. We use this stuff every single day, for everything from gassing up our cars to making the plastics all around us. But have you ever really stopped and wondered about its incredible journey? How does life from millions of years ago turn into the fuel we use today? And what kind of geological magic keeps it all locked up miles beneath our feet? Well, let's find out. So, first things first, let's start with the absolute basics. What is petroleum, really? Turns out the answer is all about chemistry. At its very heart, petroleum is an organic compound. Now, that just means it's built around carbon. To be more specific, it's this incredibly complex cocktail of things called hydrocarbons, which are just molecules made of hydrogen and carbon atoms. They can be super simple, like methane, or these incredibly long, heavy chains. But they are the absolute fundamental building blocks of all petroleum. Now, here's where it gets really cool. This natural mix of hydrocarbons isn't just one thing. Nope. Depending on the exact molecules you're dealing with and the intense conditions deep underground, it can show up as a gas, what we call natural gas, or a liquid, which we all know as crude oil. It can even be a thick, almost solid goo, like tar and bitumen. They're all part of the same big petroleum family. Okay, so we've got this mix of hydrocarbons deep down in the earth, but for it to be of any use to us, it has to get concentrated in one spot. And that is where geology takes the driver's seat, creating these amazing natural traps that literally catch and hold on to petroleum for millions of years. One of the most common and, frankly, one of the most effective of these natural containers is something called an anticline. Just picture it. Immense geological forces are bending and folding these huge layers of sedimentary rock, pushing them up into a giant arch shape. And that arch, it becomes the absolute perfect spot to trap oil and gas as it tries to move upward. So here's the play-by-play of how that happens. First, you have these incredible pressures that fold the rock layers up. Then, the petroleum, which comes from a source rock way down below, starts to migrate upwards. Now, since oil and gas are lighter than water, they literally float up through porous rock, think of it like a sponge, and they push the water that was already there down and out of the way. This upward journey keeps going until, bam, it hits a layer it can't get through, an impermeable layer we call a cap rock. This thing acts like a perfect lid, stopping any escape and letting all that oil and gas pile up right at the very top of the arch. But here's the thing. Finding one of these anticlines full of oil doesn't automatically mean you've struck it rich. Not even close. This brings us to a really, really important distinction, especially when we talk money. The difference between a simple trap and a valuable reservoir. See, a trap is just the geological container. It's the box that's holding the petroleum. But a reservoir is a trap where you can actually get that petroleum out of the ground in a way that makes economic sense. And that one little word, economically, changes absolutely everything. And this quote from our source material really just nails it. It says, discovering a petroleum trap does not necessarily mean that petroleum can be produced, recovered, economically from it. Finding the oil is just step one. The real billion-dollar question is, can you afford to actually get it out? So what is it that makes a trap worth the effort? What makes it economically viable? Well, the answer isn't just about the cool shape of the trap anymore. The difference between a totally useless find and a multi-billion-dollar reservoir, it all comes down to the physical properties of the rock itself. So what is it? What are those key factors, those make or break details that decide whether all that trapped oil is a priceless resource or just a geological curiosity? It pretty much boils down at two huge factors. First, the total quantity of oil that's in there. You gotta ask, is it a thimble's worth or is it an ocean? And second, the production rate. How fast can you get that oil flowing out? Because a slow little trickle might not even be enough to cover the massive costs of drilling in the first place. So you've got quantity and you've got rate. These are the two pillars of whether this whole thing makes money. And what's kind of amazing is that both of these critical multi-billion-dollar factors are controlled by one single fundamental thing. And that is the physical properties of the reservoir rock itself. That's it. It's not about the trap's shape anymore, it's all about the nature of the rock that makes up that trap. It kind of works like this.
You have some properties of the rock that determine the total volume it can hold. That's the ultimate size of the prize, right? Then you have other totally different properties that dictate the production rate, how fast you can get it out. And then a third set of properties determines what we call the recoverable fraction. Basically, how much of that oil it's even physically possible to extract. Because believe me, you can never get 100% of it out.
And that right there is the whole game. Understanding these specific rock properties, things like porosity, which is how much empty space the rock has to hold oil, and permeability, which is how well connected those spaces are to let it flow, that is the absolute foundation of petroleum engineering. It's how companies decide where to drill and what a new discovery is really worth. So I'll just leave you with this thought. If you think of a reservoir rock as a giant underground sponge that's just soaked in oil, what properties of that sponge would you need to measure? What would tell you exactly how much oil it's holding? And just as importantly, how easily you could actually squeeze all that valuable oil out?